this video, I'd like to discuss a typical Newton's second law question that you can expect in grade 11 and grade 12 examinations. So it's the grade 11 November 2020 exam discussion on question 2. The first part of the question is rather straightforward. Name and state the law of physics that is applied in the following real life situation. So, a firefighter has to hold on tightly on the nozzle end of a fire hose while putting a fire out. So the water exerts action force on the hose. So the firefighters are exerting the reaction force. So this is a typical application of Newton's third law, which states that if object A exerts a force on object B will exert an equal but opposite force on object A. The second question has two blocks. A 7 kg and a 5 kg block, respectively, are connected by a light inextensible string that runs over a frictionless pulley, as shown in the diagram. The 7 kg block is pulled to the left by a force of 78 newtons. So this is F applied at an angle of 12 degrees to the horizontal. The 7 kg block experiences a frictional force of 6 newtons. The coefficient of friction between the 5 kg block and the surface of the inclined plane is 0.18. Now, this 0.18 is the ratio between the kinetic friction and the normal force on the 5 kg object. Now, whenever you have two objects joined together by a string, you see the two objects as individuals, and it's going to be a case of an application of Newton's second law. Where the acceleration is directly proportional to the net force applied and inversely proportional to the mass. But that's not what the question is. They don't want us to state Newton's second law. The first question, 221, says draw a labeled free-body diagram showing all the forces on the 5 kg object. So first of all, if the question is worth 4 marks, there will be 4 forces involved here. So question 2.2.1. Obviously, there will be a force of gravity. There would be a normal force. There would be a frictional force. And there is a tension in the string. Now, the tension in the string and the frictional force, they are parallel to the surface, and the normal is perpendicular to that surface. So we need to just keep that in mind. Another thing that we need to keep in mind is that there is a component of the gravitational force that is perpendicular to the plane, and there is a component of the gravitational force that is parallel to the plane. And the angle between the component that is perpendicular to the plane and the component that is, and the weight, that angle there would be the same as the angle of the incline, which is 30 degrees. In any case, that's not part of the answer. I just wanted to show you those forces. Question 222 says, calculate the frictional force between the 5 kg block and the surface of the incline. So question 2.2.2. Now, the frictional force would be equal to mu k times the normal force. Now, this normal force would be equal to the component of the weight that is perpendicular to the plane. So the gravitational force would be mg, and the Fg perpendicular would be the x component or the cos component of 30 degrees. So that would be the normal force, and the mu k is 0.18. The mass is 5 times 9.8 cos of 30 degrees. And when you use your calculator there, you will get the frictional force of 7.64 newtons. Now we move into the next level. The next level requires us to determine the acceleration of the 7 kg block, but the two blocks are tied together. So the acceleration of the 7 kg would be the acceleration of this 5 kg, and it is equal to the acceleration of the system. Now, to solve this question, we need the force diagram for the 5 kg mass, but we also need the force diagram for the 7 kg mass. So I'm going to draw it here. The 7 kg mass has a weight Fg and a normal force Fn. It's got a friction Fk, but there is also a tension, and this tension here on the 7 kg is the same as the tension here on the 5 kg. And then we've got an applied force. That makes an angle of 12 degrees to the horizontal. Now, there are two unknowns in this situation. The acceleration is unknown, and the tension in the string here is also unknown. If you have two objects, you would usually have two unknowns. So you would need to set up two equations using Newton's second law. So using Newton's second law, F net is ma, but for the 7 kg object, the ma would be equal to. Now, the block is moving in the direction of the parallel component of the applied force. So that is the x component of the applied force. And I'm choosing to the left as my positive direction. So this is Fx minus the tension in the string minus frictional force. So here we go. The mass is 7. Acceleration is unknown. If x is F applied, so it's the 78 cos of 12 degrees. The tension we don't know, and the friction is given as 6 newtons. So if we want to simplify this, Fa equals 78 cos 12 is 76.295, so we'll make it 0.3. I'm going to subtract 6 from that just to simplify the numbers. So this becomes 70.3 minus t. 2 unknowns, I need a second equation. That second equation, I'm going to use the 5 kg object. So we start with MA, or the 5 kg, F net, is equal to, tension is towards the left up the plane, minus the friction, Fk, minus the component of the weight that is parallel to the plane. So we have mass is 5, A is unknown, tension is unknown, friction is 7.64, and this component is mass times gravity, it's the weight, mass times gravity, times gravitational acceleration, sine 30 degrees. So it is the 5 times 9.8 sine 30 degrees. That's that purple part that we've got here, that part there. Right. So to simplify the numbers there, 5A equals T, and we've got 7.64 and 5 times 9.8 sine 30. That gives us a 32.14. And this is the second equation in our problem solving here. Right, so now we say 1 plus 2, because the tension in the one equation is positive and in the other equation it's negative. We get 12A equals, tensions cancel, and this is 32.14 subtracted from 70.3, and you get 38.16, and you divide that by 12 to get the answer of 3.16 meters per second squared, and it would be to the left. Right. Next question is 224. It says calculate the tension in the string. If you can use equation 1 or equation 2 to solve this problem, I'm going to use equation 2. So it's 5 times the 3.16 is the tension minus 32.14. And if you do your mathematics there, the tension becomes 48.04 newtons. Right, let's move to the next question. And let's clear all these things. Last part of the question says, what would happen to the friction on the 7 kg block if this 78 Newton force, if that angle that the 78 Newton force acts is reduced to 0. Now, this 78 Newton force has a vertical component and a horizontal component. Now, this vertical component is in the same direction as the normal force. So the normal force and the vertical force of the applied is cancelled out by the weight of the object. So Fg is equal in size to Fn plus Fv. Now, what happens to Fv when the angle theta becomes 0? Fv will be 0. In that case, the gravitational force would be equal to the normal force, which is much bigger than what it would have been if there was a v, Fv. So if theta is decreased to 0, the vertical component of the applied force is 0, and then your normal force will increase in strength. So it would increase is the answer to this question. Explain, I'm busy doing the explanation here. So your frictional force is directly proportional to your normal force. And I get that from this equation. Fk is mu k Fn. So if that is the case, and the normal force is increased, then the frictional force will also increase. Thank you for watching this video.